Okay, a very good morning. Assalamualaikum warahmatullahi wabarakatuh. Student, can you hear me? Students, can you hear my?
Yes, Doctor, we can hear you.
All right, thank you. All right, so please write your names in the chat box with your metric number, yeah? Okay, so meanwhile, I will start my, let me share with my slide. Okay, students, so today we have a discussion, okay? Basically, it's a discussion feedback on our group discussion for the second week and third week, okay? So once we finish this one, so that's mean we've done our part for the trace analysis and also sample decomposition, okay? And next week we will move to the new topics. Okay, so the first question for the group discussion for the first one, okay, I hope you still remember that there is a two question based on this procedure, okay. So this procedure is basically is about the analysis for the metals of in sediments, okay, in Juru and Jajawi estuaries, okay. So the first question is, which step is more important in this procedure? So basically, I give I divide by two. One is a sampling part and one is a analysis part. Okay. So based on your discussion, okay, from these 7 groups, I realized that, okay, 6 groups able to answer the right question, answer the right question. Okay. Only one unable to give the choose. When we want to choose also, you're unable to choose. Okay, never mind. Okay, because this is just the first part of the group discussion. Okay, slowly you will develop when you start to discuss with your friends. Okay, so the first one, okay, most of you managed to answer. The answer is this procedure, which is a sampling. Okay, so all of you be able to identify this is a sampling process and this is the analysis process. Okay, so why this sampling is important? Okay, most of you also managed to give the answer is correct. Okay, the answer is because the sampling is, as we know that the sampling is the first part. Okay, the first step in our procedure. Okay, so if let's say and your sampling, okay, should represent your results. Okay, so if your sampling process, okay, is something wrong with your sampling process, that means they will give the effect to your accuracy of your results. Okay, so that means, let's say that I choose something, maybe when I do the sampling process, the first thing, maybe the point that I choose with this in the Juru and Jajawi, I not choose the right point. Okay, in this case, maybe they will affect until the end of your results here. Okay, so when you do the analysis, your result now is it's no point you get that result, because your result is, we cannot rely on your result because it's no more accuracy when we talk about the result at the end of this part, because at the first part also you already start do the wrong things. Okay, so sampling is very important because it represent your, at the end, your results. Okay, so the accuracy is depend on the first part, which is the sampling. Of course, the analysis process also, this part also important, but in terms of weightage, which one is more important? Of course, the answer should be sampling part. Okay. Okay, now the second one, identify and discuss the error that occur during the process. Okay, So you can see here that I underline few clue here. Okay, so here I would like to share, okay, few things. One is the clue is a sampling. Okay, I think only one or two groups only not touch about the sampling. The rest, they managed to say that the sampling is one of the concern about the error. Okay, so and what is the possibility of the error that can be happen during the sampling? Okay, for examples, okay, here you can see here is a 5 field trips. Okay, 5 field trips. Normally, when we want to do the, let's say that your objective, you want to know that certain the concentration of this sediment at the Juru and Jejavis, okay, and some of your metal is quite volatile. Okay, so in this case, your time that you want to take your sampling also very important. Let's say that maybe the first field trip you take at the morning, okay, and the second one you do at the during afternoon, okay, maybe around 12 o'clock, okay, during sunny day, and then some of your metal maybe already volatile, okay, and the third day, the third times maybe you take during the rainy day, okay. So all these things might be will give error, okay, to your analysis, because some of maybe when you take at a different time, okay, some of your metals will be volatiles, okay. So it's not you cannot get the accurate result every time you want to do the monitoring in this particular area, okay. So during the sampling, one of the most important thing that you should focus should concern is, one is the point, okay, how many point during these 5 field trips, okay, because the point will be represent, okay, overall of your results, okay. As I mentioned just now, your sampling should be represent, okay. So is something wrong with the point that you take also will be, might be give possible it's not represent your result, okay. Might be also when let's say that the first time you take the different point with the second times, okay, that also is not represent, also that is something error that we cannot, sometimes we cannot calculate. The second one is might be happen when the sampling itself you take at a different time, okay, different day, different times, okay, rainy day or sunny day or something, that also will be effect of your results, okay. Sampling also will be affected when, let's say that you choose, you take the sampling with a not proper container, okay. Let's say that you keep in the let's say that in this case, for examples, okay, if you take the sediment and you keep in the plastic bags, or some of you keep in the bottle jar, okay, it's a glass bottle, okay, all these things will be give the error to your analysis, okay. The container itself is very important, okay. And the second one here is I mentioned about, I underline about the gauge auger, okay, which is your sampler. You want to take the sample, okay, let's say that this is your point, the sediment, the first sediment you take, okay. After that, you go to the second point, but you never rinse out your sampler. You just simply take from the first point, you go to the second point, and then you take the second point of sample from the second point, and then you go to the third point, okay, without you clean your sampler. That one will be give very high error to your analysis. Why? That is might be the query over from the previous samples, okay. So that one also you have to be very careful when you handle your sampler. Make sure from one point to another point, please rinse with the Janus water or Atropia water, then only you can go to the second point, okay. And then when you bring back to the laboratory, okay, anything can be happen, okay. The losses of the some metals during you bring back to laboratory, if not proper, you're not proper preserve and so on, okay. During you do a dry and grind with the pestle and mortar, okay. This one, if let's say that from one, as I mentioned just now, from one sample to another samples, you just maybe you just use tissue, say that, okay, I just clean like this, and then you put the second sediments and then you grind it. Okay, the possible of the carryover from the first sample can be contaminate your second samples. Okay, so might be the contamination can come from your apparatus itself. Okay, there is a lot here, but I identify few things only here. Okay, and concentrate is nitric acid. Why I'm concerned about the nitric acid here? Okay, because this is one of the reagent that you use, and at the end, the nitric acid will be together with your samples, with your metals, your targeted metal will be detected by the atomic absorption spectroscopy. Here, if let's say that you choose, let's say that suddenly you don't have enough nitric acid in your lab, and then say that, oh, what I want to do. Okay, so let's say that, okay, as for information, all our laboratory for the analysis in the level 5 in the Bangunan Makmal Kimia. So let's say that, oh, I'm finished the nitric acid, then you go to the level 8, which is the organic. Okay, normally the organic person, maybe they have the nitric acid, but they have a synthesis grade. Okay, so for us as an analytical chemist, we are so concerned about the grade of the reagent. Okay, we are so concerned about the grade of the reagent. Okay, we won't use any grade that like synthesis grade for the analysis. Why? Because at the end, if your reagent is not pure, they will give effect to your analysis. Okay, might be inside your nitric acid also there is some present of any impurities of the metals. Okay, so that's why when you want to buy, why you want to purchase your nitric acid for the analysis purpose, please buy, normally we say AR grade. Okay, analytical grade. Okay, or we call as analytical grade, or maybe we have a more pure than the analytical grade, which is we call is a what we call I also forgot. This is a pure grade something. So sorry lah, I forgot. Okay, so normally when you want to purchase, we make sure that we concern about the grade of the reagent, because it's very important when you want to do the analysis. They will affect. So check the impurities or everything, then only you can purchase. Okay, now I highlight here is a Teflon vessel. Why I've mentioned about the Teflon vessel? If let's say that your Teflon vessel is not proper and you are not clean properly, okay, might be the carryover can from the previous sample can be contaminate your samples. Okay, so your Teflon vessel should be clean properly, then only you can use for the next analysis. Okay, so why I'm underline the flame atomic absorption spectrophotometer. So I believe now you are in the stage that learn about atomic absorption spectrophotometer from Dr. Kok Sok Mei. There is a lot of interference during the flame atomic absorption spectrophotometer. Okay, there might be spectral interference, whatever. So the interference come from the flame also is one of the error that can be effect to your result. Okay, and why I underline this part, copper, zinc, cadmium, lead ores, okay, is referring to the preparation of your standard solution. So when you want to analyze your sample, first of all, you have to calibrate your instrument. In order you want to calibrate your instrument, you must have the standard solution. Okay, you must have the standard solution. You must prepare the standard solution. Your standard solution should be prepared freshly. Okay, students, listen. Okay, this one is very important for you one day become as a chemist. Okay, let's say that you want to do analysis of the copper, zinc, cadmium today. So you should prepare the standard freshly by today. Don't keep, okay, you say that, oh, mahal this standard, I want to keep for one whole semester. Please don't, okay? Because normally when we play around with the standard solution, the concentration is very low. Maybe 1 ppb or 2 ppb in the ppb level or ppm level, maybe 1 ppm, 2 ppm. Okay, normally the range of the analysis in the atomic absorption spectroscopy, I give the example, let's say that copper, the range that normally we use only from 1 to 5 ppm normally, okay, 1 to 5 ppm. So you cannot take this, you say that, oh, this is very hard, I prepared this one to 5 ppm series of the standard solution. I want to keep for one semester. No, you cannot keep. Even though you keep in the fridge also, you cannot get the accurate results. So if you're something wrong with your standard, they will affect your results. Okay. So if you cannot get the linear calibration curve, they will affect your result. So please bear in your mind, okay, make sure that you know that if one day you become a chemist, the calibration is one of the first part that very important in analysis part. Okay, this is, when we go here, this is analysis part, okay, analysis step. Okay, calibration is one of the main concerns that you should make sure prepare properly. Use all the volumetric apparatus, okay, micropipette or pipette, whatever, volumetric flask and so on, okay. So if you choose the wrong apparatus, also will affect your results, okay. So if you do a wrong calculation, whatever, they will affect your result in your analysis, okay. If you say that this is 1 ppm copper, but actually the real the concentration only is a 0.5. Of course, the system, when you say that it's a 1 ppm, okay, you will set in the instrument is a 1 ppm. So they will affect to your results, okay. And the third one, the last one here, okay, why I underline the cold vapor atomic absorption spectrophotometer. This one also is instrument, so the instrumentation also can give the error, okay. So there will be effect here, okay. So the last part you can see, you also will digest the same way with the blank acid. Okay, so anything, okay, in analysis, whatever you digest your samples, you should digest the same way with your blank. Okay, this is for your information. Make sure you have the blank with you. Okay, so what is your blank? That means only the acid mixture without your sediment. So that is your blank. Why we must have the blank? Because we want to trace back. Okay, if let's say there is any contamination, you can detect from your blank analysis. Okay. So here I give one of, and again I would like to stress about how important the error, okay, in analysis. Okay, let's say this is one of the beaker. Okay, let's say you want to detect mercury in this beaker. Okay, mercury in this beaker. Sorry, in these liquid samples. Let's say this is a drinking water samples, and then you want to identify the mercury in these drinking water samples. Okay, let's say one of you, okay, take this sample from our lake water from Tasikmar City. Okay, I hope all of you still remember. In UM we have one lake. Okay, we call it a Tasikmar City. Okay, so we take the this. Let's say that one of your group, okay, take this lake water or lake water, and then you want to do the analysis of the mercury. Okay, there is a two groups here. Okay, let's say one group take using the glass bottle. Then another group take with the PTFE. Maybe they use some plastic bottle, PTFE. Okay, and another group take with the glass bottles. Do you think, okay, let's say group 1 take with the glass, group 2 take with the plastic bottles. Do you think they will affect your analysis or not? Anyone can answer? Anyone? Otherwise, I have to call your name. Students? Okay, let me start. Call your name. Shuhada, are you here? Shuhada? Shuhada is not here. Sabri, are you here?
Yes. I think.
Okay.
Using using glass or plastic. There will be effect because mercury is heavy metal, so it might affect the plastic bottle. So some of the plastic bottle the compartment can dilute into the water sample.
All right. Okay, that is a answer from Sabri. Good attempt. Okay, at least you try to relate with the container with the mercury. Okay. One more from Devika. Are you here, Devika? Devika, are you here? All right, Devika is not here, I think. Ko Laimun?
Yes, doctor.
Yes. What do you think? What's your opinion?
I think because of the use of plastic, it's not suitable for storing mercury, because I think using plastic bottle to store mercury may cause like mercury to absorb thermal energy from the surrounding compared to using glass. So it might
So which one you
result
will
in
advise?
extractions.
Using the glass bottle.
Yeah.
All right. Okay, thank you. I think his answer is almost same with Sabri just now. Okay, thank you, Ko Laimun and Sabri. Okay, so basically, okay, the answer is, of course, they will affect when you choose the different container. Okay, in this case, we have a plastic and also glass. Okay, so here, let's say that you have a mercury and you have another group of the organic. You want to do, you have two groups. Okay. One group want to do organic analysis and one group want to do the method analysis. Okay, here we are focusing on mercury. Okay, so for mercury or any other metals, you should use the plastic bottles. Okay, PTFE bottles or whatever must be plastics. And for organic, must be glass bottles. That is the rules. Okay, analysis. Okay, please, okay, keep in your mind this one. For organic, you must make sure you use the glass. Okay, for mercury or any metals analysis, you should play around with the plastic bottles. So sometimes if we know that the concentration is very low, maybe in part per billion or trillion, normally until the volumetric flux also will ensure there is a, we play around with the, we avoid with the any glass contact for metals. We try to avoid any glass contact, the from starting from the spatula or whatever, the beaker in of our lab. Okay, so we know that, okay, when we see all the one person that use all is a plastic, we know that, oh, this group is a metal analysis group. And another group, you can see that they play around everything. The apparatus should be in the glass and they avoid all the plastic. And then you will know that, oh, this analytic chemist is belongs under organic analysis. Okay. Why? Because metals can contact with the glass. Okay. Metal can contact with the glass because glass have a silicate. One of the materials inside the glass is a silicates. Okay. So this glass can be contact with your metals. Okay. So when there is an adsorption happen between the mercury or metals with your glass, so the process of the adsorption, okay, will be happen. Adsorption and desorption, okay, will be happen. Sorry, only adsorption will be happen, okay. The adsorption will be happen, which is they will affect your results. Okay, let's say that you can detect mercury like this, but once after you keep in your bottle sample, maybe the concentration of the mercury will be decreased because of that. Okay. So the second one, why we should avoid the organic with the all the plastic bottles? Because the organic should be because as we know that, okay, in our plastic bottle there is a made of the some polymers, and these polymers can be released and then they can contaminate your samples. Okay, so we don't want any leaching out from your plastic bottle and disturb your analysis. So that's why we must avoid all the plastic bottle, and the organic very suitable for the glass bottle. Okay, so this is how important the container. So starting you take during the sampling until the end, okay, during the analysis, you make sure that you choose the proper apparatus. Okay, so you can see here, okay, there is a 15 possibility of the error can be happen here. Okay, there is a effect of the from the, let's say number one is a contact of the air sample with the laboratory air. Okay, for example here, okay, you are the first batch do the analysis of the mercury, and some of your mercury might be will be go to the airborne. Okay, so your lab will be there is a presence of the mercury. Okay, mercury actually at the room temperature easily can vaporize. Okay, you are not closed properly, so some of them is now in your lab. And then the second batch want to do the analysis, and this is their beaker. And when they do the exposed to the our environment in the lab, so there is a cross contamination from the previous batch. Okay, so this is number one. Number two might be come from the residue of your dishwashing mixture. Okay, anything when you want to wash, okay, sometimes can be your residue. Okay, or is contamination from distilled water, or contamination from the reagent, contamination from the contact with your analyze, and so on. Okay, so all these things might be happen in during your analysis. Okay, so that's why we are so concerned about the try to minimize any effect, the factor that contribute to the error. All right, so even as I mentioned just now, the apparatus is very important, and also the way you want to wash your apparatus also very important. Okay, for meta-analysis person, they will wash all the apparatus. Okay, normally like me last time. Okay, when I deal with the meta-analysis, I will rinse all. Okay, I will soak all the apparatus in the nitric acid solution. Okay, we are prepared like there is a certain percentage, so we prepare the nitric acid solution, and then we soak all our apparatus inside there, and the next day we will rinse and wash with the deionized water. For the organic, we will use another dishwasher that's suitable for the organic. So why? Because as I mentioned just now, there is a carryover from your metals and so on. Okay, so you want to make sure you get rid all your any contamination. Okay, to make sure that your container is very clean, you should rinse with the nitric acid, or any normally is nitric acid or some HCl and so on. Why? Because this acid can solubilize all your metals. Okay, so they will be solubilized, so they will get rid from your container and so on. Okay, so that's about the factor that might be contribute to your error. Okay, I'm done for that part. So now the second part is we discuss about the group discussion for number 2, which is about sample decomposition. Okay, so most of you, I can see that they can answer the right part for this number 1, but 1 or 2 they're still confused, but it's okay. Okay, we're trying to do a brainstorming, okay, to understand and to relate what you understand from my lecture to this question. So it should be okay, no problem. Okay, so the first one, the clue is volatile metals. Okay, you would like to do an analysis of volatile metal. The first thing, as we know that volatile means normally is easily can vaporize. Okay, so only few metals that easily can be volatile. Okay, as I mentioned just now, one of this is a mercury, lead. All these are categorized as volatile metals. So in this case, you cannot simply treat the same way for the volatile with the non-volatile metals. Okay, volatile metal is very quite sensitive, so we cannot just use the open system. Okay, in our my lecture, I give you 3 types. One is a dry etching, wet digestion, and wet digestion, which is conventional heating, and the microwave part. Okay. As I mentioned during the lectures, okay, the third lectures, the dry etching will be the process of the dry etching. They will be produce the evaporation of the moisture. The second step, evaporation of the volatile materials. So let's say that means they will get rid all the volatile metals. Okay, so volatile materials. Okay, and then only they will burn off your organic compounds, organic matrices. So in this case, dry etching is not suitable at all, because they will be get rid all your volatile metal, because your volatile metal here is now your targeted analyte. The targeted analyte, it cannot get rid just like simply at the open system, you just get rid all your volatile metal. So dry etching is not suitable. So we have two more options: wet digestion, either conventional or microwave. As I mentioned during my lectures, the conventional heating is still an open system. Even though you just close with some battery dish or whatever on top of your beaker, it still is an open system. Okay, your volatile metal can be easily evaporate from here. So not suitable because it's an open system. So the volatile metal only is suitable for the closed system, which is a microwave. Okay, students, so let's say that you want to do some analysis of the mercury in drinking water or in fish or whatever. So the best choice is a wet digestion using the microwave. Okay, because it's a closed system, so you can minimize the loss of your volatile metal, which is your targeted analyte. Okay. The second one, Amira used 10 ml nitric acid to digest the tea leaf using microwave, to determine the copper and lead. Can she use the same method to digest the soil samples for determination of copper and lead? So basically, the targeted analyte is the same. Okay, so we don't have any issue. Okay, the clue is here: tea leaf and the soil samples. So most of you managed to answer. Say that the answer is no, because the matrix is different. The tea leaf, most of the tea, as we know that tea leaf, they contain a lot of the organic matrices. Meanwhile, for the soil, there is a combination of the organic and inorganic matrices. As I mentioned before this, during the explanation of the sample prep, one of the main things when you want to choose the method, you should make sure that what type of matrices that you want to do the analysis. Because when you have a different matrices, might be you have to choose a different type of the reagent. Okay, so same goes here. Okay, when you want to change from tea leaf to soil sample, you have to change your reagent in this case. Maybe you have to add on, instead of nitric acid alone, you have to add one more acid to do the complete digestion of the soil, because normally soil, as I mentioned just now, there is an inorganic and organic. So for information, soil, if you there is one of the part that is present in the soil is a silicate. Okay, so silicate is one of the things that present in your there is one of the matrices. So when the silicate, as I mentioned in my lecture, acid hydrofluoric is one of the best acids to digest. Okay, it depends. If you want to do a complete dissolution, then soil HF with the acid nitrate is the best. But let's say that maybe you want to just do you don't want to do a complete dissolution of the samples. You just want to take the surface of the soil only. You want to cut off all the bind of the metals on the surface of the soil. Might be HCl is just enough, but then might be cannot dissolve all your soil samples. So it depends your but you must have either HCl or HF to do a decomposition of the inorganic matrices. Without this, you cannot do the decomposition of your inorganic matrices. So what we can say that the summary from this question number 2. Normally for the reagent for the sample decomposition, we need combination of the nitric acid or other acid with the HCl or HF, or maybe we have to add the perchloric acid or hydrogen peroxide to enhance the oxidation agent. It's very rare we just use a single reagent. It's not easy to digest it, or it's not easy to do a complete dissolution process. So the combination will help us, as we know that most of our matrices present of these two inorganic or organic matrices. Okay. Discuss one disadvantages of the wet acid digestion system. Okay. So most of you, I think, managed give the one of the disadvantages. Actually, we can list out some of the disadvantages. It depends, okay, what type. Either is a conventional heating or we're talking about microwave. Let's say that incomplete dissolution. Sometimes this is one of the big issue in the wet acid digestion, incomplete dissolution. Even though you use the microwave, let's say that I'm using microwave, it's okay lah. Any reagent also can do because it's very efficient. No, even though microwave digestion is very efficient, but we still depend on what type of the reagent. Okay, what type of reagent is very important. Okay, so in this case, let's say that you choose wrong reagent, okay, which is this reagent is not suitable to digest, to complete do digestion of your samples. So at the end will give your effect to your result, because if let's say that it's incomplete dissolution, might be you cannot get the overall picture of your analysis of your metal inside their samples. Okay, so the incomplete dissolution might be can happen in the either open system like a conventional heating or in the closed system like in the microwave. Airborne contamination normally is happen if you use the conventional heating process in the open system. Okay, because you put in the all the beaker, okay, in a fume coat, and then you heat up. Okay, so there is an airborne contamination during you do the analysis. Okay, so some of your targeted analyte will be evaporate. Also might be they will go to the close contact with the beaker next to you of this beaker. Okay, and also the loss of the targeted analyte. Maybe we have this issue, but we are talking about open system, might be happen. Okay, so if let's say there is a beaker, so some of them will be lost. Okay, maybe because of the evaporation or maybe the contact with your beaker or someone. Okay, so the last one is might be something there is a potential of the violent reaction. Okay, explosion can be happen if you are not choose a proper procedure. Okay, for example, I give, okay, let's say that you want to do analysis of the some samples using nitric acid with the hydrogen peroxide. In this case, you cannot just you just take one samples and then you add nitric acid and then directly you add hydrogen peroxide. Please, okay. If not, there is a violent reaction can be happen. So what you should do? Normally, I will advise my student, okay, add nitric acid, okay, and then digest first. Okay, digest first. So some of the matrices, that very simple matrices, they will be contact with your nitric acid. Okay, so we call it a complete the pre-digestion of the some matrices. Okay, after that only, okay, maybe after you can see there's some color changes or something else, and then only you will add the hydrogen peroxide. So what is the hydrogen peroxide function after that? To complete the reaction, okay, to make it all the stubborn matrices, okay, they will do all the complete dissolution. So then we add but before you want to add the hydrogen peroxide, normally we advise the student to put down your samples, make it cool first a bit, and then you add the hydrogen peroxide. Once you add the hydrogen peroxide, you can see very clear some bubbles will come out. Okay, that's mean the process of the oxidation will be happen during that time. Okay, so normally once you add the hydrogen peroxide, you can see all your sample will be clear. They will complete dissolve, and then all the bubbles also no more longer. You can see the bubbles and very clear, and then you will stop the reaction. Okay, so that's how we handle the reagent. Okay, same goes with the perchloric acid. You are not just take the acid with the perchloric and then digest. Okay, either you add one by one or you want to add both, but you have to leave it. Normally we leave it sometimes one day, and then with the next day only we'll start do the digestion process. Okay, so here are some other example you can see. Okay, the method that they will use for the analysis of, they choose two analysis, two method. Okay, so here they mention about they digest with the 0.5 of gram of samples with the 12 ml of the aqua regia. Okay, so why I emphasize about this one? Okay, sometimes we use these terms. Okay, so one day when you go become as a chemist, when your boss asks you to do a digestion and then you find this method and then suddenly you mention aqua regia. Okay, so please don't panic. Aqua regia is referring to the combination of the nitric acid and HCl. Okay, we call it an aqua regia. So nitric acid, there is some ratio, if not mistaken, 3 of nitric acid and 1 hydrochloric acid. Okay, 3 to 1. Okay, so why we call it a aqua regia? Okay, aqua regia means we call it a royal water. Okay, it's a royal water. Royal water is because this acid can able to dissolve the gold. Okay, so they can, if let's say that you have extra gold at home, so you can use the nitric acid and hydrochloric acid to dissolve the gold. Okay, so that's why we call it a royal water. Okay, and you can see here, if let's say that there is a they mention about silicates. Okay, so normally they will give combination of the nitric acid with the HF, as I mentioned just now. Okay, so that's all for the discussion for the number 1 and the first one and the second one. So I really hope that you are very clear, okay, about this from the trace analysis. We are talking about the error. We're talking about the sample decomposition, okay, how you want to deal with your samples. Okay, so all this extra information is very important because one day you will become as a chemist, you will deal with any samples, okay, in the lab. Okay, so you should have some basic concept how you want to deal with all these samples. Okay. Okay. This topic actually is not in your performa. Okay, but I will upload in the Teams later on. Okay, the details about this one. One day, maybe when you become as a chemist, you need this information. Okay, so that's why I think it's quite important for all of you. So I will upload in the Teams and also if I or in Spectrum, but most of the time with the extra information I will upload in the Teams later on. Okay, so I have only 5 minutes. I will simplify here. Okay, I will simplify it. Okay, students, okay, can you see this paper? Students?
Yes.
All right. Okay, this is one of my analysis. Okay, one of my PhD students, Siti Halija, currently now is in lecturer in UNIMED. Okay, so this girl do analysis of the polycyclic aromatic hydrocarbon in sewage, slush, and landfill. Okay, so this girl do the method development, develop the some material from waste cooking oil for do a pre-concentration of the polycyclic aromatic hydrocarbon in sewage, slush, and landfill leachate. So you can see here that at the end, the student managed to, with the material that we modified, we managed to detect the in our samples, in the real samples, which is in the slush and also in the some sediments. Okay. All right. My question is, let's say that I want to ask you to do some analysis of polycyclic aromatic hydrocarbon. Okay. But instead you want to detect in slush or leachate. I would like to I would like to ask you to do analysis of this same analyte, but in the matrices of the matrices might be sorry. The same thing, you want to detect polycyclic aromatic hydrocarbon. Okay, let's say this girl do the experiment in okay, to detect the sewage, slush, and landfill leachate. Okay, maybe you also will take the same leachate, different leachate in the different places, and your lab will be, let's say, that in USM. Okay, I give the example. You are now in USM, and then I ask you to do this, the analysis. The question is, can you use this method for the analysis to proceed in USM? Anyone can answer this one? Do you think you can use this method?
Cannot.
Cannot. Why? Because of Sharifah Muhammad is here? What's the reason?
If I want to validate his or I want to validate her result, I need to use another method, right?
You want to validate.
Yeah,
Alright.
her result.
Yeah, there is some right terms there, is a validate. So who's there just now?
Leon.
All right, good, Leon. Okay, the answer is you can use, but before you want to use the method, you have to validate. Okay, so the answer is you still can use, but you have to validate the method. Okay, so what is a validation? Okay, so this is extra information is very important because one day when you become a chemist, you will play around all these concept, validation and so on. So that's why I would like to emphasize here. Okay, so Siti Khalijah just now developed the method. Okay, and she already validated the method. Okay, I will. So what is a validation? I will share later on. Okay, so she already validated the method, but if she want to, sorry, if she want to transfer the method, which is from UM to USM, okay, you cannot simply transfer. You must validate first, revalidation. So in this case, Leon, if you want to use, so Leon should revalidate the method. After you revalidate, then only you can transfer the method. You transfer the technology from UM to USM. So basically, method validation is like a approved, say that, okay, this Siti Khalijah's method can be used in USM. After they approve, then only you can use in USM. So what is a method validation? To demonstrate that the method is suitable for intended use and to provide assurance of reliability. So you cannot just simply, let's say that you find in the journals and then directly you want to use in your lab. Normally the method that we develop, either first, if you develop the new method, you should validate, or in our case, just now, just take from any journals, you should revalidate. After you revalidate, then only you can use the introduction into our routine analysis. Okay, why? Because any changes, okay, of the method, simple thing, your instrument will be different. Okay, your instrument will be different, your environment will be different. All this condition will affect your method. Okay, so that's why we have to revalidate to see that how good your this method after revalidate. Okay, so in order you want to validate your sample, so this is the characteristic of your sample that you should have, your method should have. Okay, your method should be sensitive enough, your method should be precise, accurate, your method have a low limit of detection, limit of determination, selectivity, range, and so on. Okay, so later on I will upload. So one day you can save that notes. Okay, so one day if you need, then you check what is the meaning of the definition of the sensitivity, precision, accuracy, limit of detection, and so on, because it's very important. Okay, where my pointer here? Cannot see. Okay, never mind. I cannot write anything because I cannot see my pointer suddenly missing. Pointer ocean. Okay. All right. Okay. I give a very simple concept for the sensitivity. What is the sensitivity? Let's say that this one method, you have a two instrument, two UV. One UV, two chromatography, HPLC. You have a two HPLC. You want to detect 1 ppm of bisphenol A. Okay, this is a signal for the instrument number 1, and this is a signal for instrument number 2. Which one is a sensitive? Number 1 or number 2? Anyone can answer?
2.
Yes. So the instrument number 2 is a sensitive enough. So the sensitivity is one of the important things that we should determine. Okay, is it your method is sensitive? If yes, what is the sensitivity value? Okay, so that is how you have to validate your method. Precision. So what is a precision? Let's say that you run 5 times. Okay, 5 series of standard solution. Okay, or 5 series of your samples. You run 5 times. Okay, the things that you want to know that is it every time you run your result will be close each other. Okay, if your result, okay, normally this precision we will present through RSD. So maybe I'm not sure that maybe during your class later on in your lab, okay, you have to calculate the relative standard deviation. Okay, so relative standard deviation is present how precise your method, how good your method. Okay, is it every time you run you will get almost the result will be acceptable as a precise or not. Okay, and the best precision should be less than 5%. So less than 5% of the RSD shows that your method is good enough, is a precise. Accuracy means is when you run, let's say that you know that the concentration of your sample is 1 ppm. Okay, this is your the accurate results. Okay, it's a 1 ppm, which this method when you run your samples, you only get 0.8 ppm. Okay, so when you calculate the accuracy, only 80%. Okay, in analysis, okay, the acceptable value for the accuracy is 80 to 120. Okay, 80 to 120 is acceptable for accuracy of the method. Okay, as long your method in this range, as the analytical chemist will be accepted. Okay, the rest is you can read from my notes, but this one only I will like to emphasize, then we will end our class. Okay, so limit of detection. So what is the limit of detection? The lowest value that your instrument can be detect. Okay, so that is the limit of detection. So based on this value, you can know that how good your instrument. Okay, let's say that one instrument can detect the limit of detection is 0.1 ppm. Another method can detect until 0.1 ppb. Okay, this is HPLC number 1 and this is HPLC number 2. Which one you will choose? Student, which one you will choose?
Billion number 2, maybe.
Yes, correct. All right. So you choose when you see the method. Okay, the main characteristic that we are very concerned is the limit of detection. Of course, for me, I will choose 0.1 ppb. Why? Because that means the instrument can detect until 0.1 ppb level. So it's very sensitive enough. So I will proceed for my analysis. Let's say that in drinking water, the concentration, the level of the safety of the drinking bisphenol A in the drinking water, let's say that is 0.1 ppm. Okay, you want to do analysis of the drinking water in the this mineral bottle, and legally is in terms of safety is a 0.1 ppm and low is the best one. Okay, above that means is dangerous to us. For example, in this case, your method when you want to choose the limit of detection should be less than 0.1 ppm. Don't take the method that 0.5 ppm. Okay, so when you want to choose the method, all these things. Okay, just now you want to choose the Siti Khadijah's method, you have to check the limit of detection, the accuracy, the sensitivity, the precision, okay, and the rest also. Okay, so you can read what about the selectivity range and linear range. Okay, but normally we'll be do the precision, accuracy, limit of detection, limit of determination, and linear range. Okay, the linear range. So this is the things that we always do another calculation for validation for the method, and then only you can apply for the real samples. Okay, so that's all from me. Okay, so the next topic for starting for next week is a chromatography. So student, anyone can say what is a chromatography in one word? What is that? What is a chromatography in one word?
Separation.
Yes, good, Sabri. Sabri, right? Who's that?
Yes.
Okay, okay, that is the right answer. Chromatography is a separation. So next week we learn about the separation technique. Okay, so that's all from my side. Okay, thank you. See you all next week. Okay, so next week we have a pre-recorded lectures. That's all from me. Thank you.
Thank you, Dr. Bye.
Thank you. Bye.
Thank you, Doctor.
Thank you, Doctor.
Welcome, my dear.